Okay. Hello. We'll be starting in like 5 minutes, but feel free to say hi in the chat. I'm going to go check all the streams. So hopefully you can see how this goes. That seems to be working. Dashboard. Pause the preview. Pause the preview. Lives go here. Turn to live. Okay. If you're joining us, I'm getting everything set up, but we'll start in a few minutes. But feel free to say hi in the chat. Feel free to say hi in the comments on LinkedIn. There's not really a chat in LinkedIn, so mostly just comments. But today we're going to be looking at Frontgrade, who provides space grade processing systems, and look at their development board, which has a Lattice CertusPro FPGA on it. And we're going to be looking at, they have a RISC-V demo they released like a month ago, about 3 weeks ago, and we're going to look at that today. Hello, Bars on YouTube. Glad to see you. Why are you here today? Are you interested in Frontgrade, Lattice, RISC-V, FPGAs in general? Got a few more people joining us. Okay. Great. Should be good. Okay, we got 2 more minutes and then we'll start. Thank you for joining us for the pre-show. We'll be looking at a example bit file provided by Frontgrade with their custom RISC-V processor. This is to demonstrate a RISC-V on a Lattice FPGA that is designed for space deployment. A very reliable FPGA because of the fabrication process. We're going to be loading the bit file using their tools, probing the design, and getting a few example software loads working on it. Awesome. Thank you for joining us. Yeah. Okay, we're about to start. So I'm FPGA Zealot, or Andrew Wilson. Today we're going to be looking at the Lattice FPGA on a Frontgrade development board. Frontgrade a few weeks ago released a example bit file with their new NOEL3 soft RISC-V processor. I wanted to explore that bit file, and I thought it'd be interesting for people to see what some companies are doing with providing open source for some of these solutions. Frontgrade's open source repository is not, like, I don't think, terribly well known, but you can download it and use their IP, which we'll talk about a little bit. So we're streaming on YouTube, Twitch, and LinkedIn. Feel free to go to whichever servers provides you the best quality for where you are. I'm trying to keep up with the comments and the chat from all the services, so we should be able to address any questions you have in the stream. And feel free to ask questions. Feel free to say hi in the chat, your interest here, and any questions about the systems we are working with today, or suggestions for future streams as well. Some disclaimers: I am not employed by Frontgrade. This is not a paid stream. They provide me the development board, and I'm just kind of exploring the example bit file that they posted a few weeks ago. So let's jump in to the FPGA we're doing. So yeah, let's start here. So we're going to be looking at the GR740-MINI, which is a really nice compact development board from Frontgrade. Talk about, okay. So the GR740 processor, which is a quad-core Leon processor, using the Spark ISA, I believe. I don't know about it here. Pull up another screen real quick. Go. GR740. So this over here. Okay, so get a little overview. Quad-core Leon processor, block diagram. Okay, here we go. So we have the quad-core Leon processor. I believe it's Spark ISA. We're talking to the CertusPro, a Lattice FPGA. And then we have the FMC with SpaceWire and SerDes. DDR, SDRAM, and FTDI chip be able to communicate with them, and being powered over USB-C and 2 Ethernets, one FPGA and one on the processor. So today we're going to be looking at a new example design for this. There are previous example designs, mostly using this one doesn't have a processor, but using a bridge to communicate with various IPs. This one has a soft Leon processor. These are examples that come with the board. And this one has the PCIe component. Was there an example for? I don't think so. Okay, so those are examples that I previously demonstrated on the FPGA Zealot YouTube channel, so you can go look at that. We looked through designs and kind of poked at them. But we want to look at a new design that's using the NOEL3 soft RISC-V processor. And this one, they wanted to go for reliability. And they have a dedicated page for examples. But what are some of the main points? A fault tolerance. Focusing on fault tolerance within the design. So they previously released the NOEL5 processor, but it's a rather feature-rich processor, and it's big and doesn't really fit on these type of FPGAs. But this type of processor is smaller and it's much easier to set up. Barrel processor architecture. So the NOEL3 is a barrel processor with multiple execution threads, hearts. Each heart executes one instruction in the pipeline at a time. The processor switches between hearts every clock cycle, so each heart executes instructions at the rate of the clock frequency divided by the number of hearts. This architecture choice improves maximum achievable frequency and provides execution predictability. Oh, that's nice. I would be really curious to look at how that logic works. I want a better block diagram. They haven't released into the grlib yet, so I think we're gonna have to wait till the new update on the grlib, but we'll talk about the grlib a little bit more. But so they have a GR740 example, and the block diagram is really basic. You have the NOEL3 core, you have instruction memory, data memory, our UART GPIO timer, and then the debug links over here. So we're gonna go look at that. A little bit more comments on the Lattice CertusPro-NX. This is a Lattice product that is upsampled. I believe it's the phrase you use by Frontgrade for space deployment. And do they talk about the... So right here, the fully depleted SOI has a really good soft air rates from in a radiation environment. This is comparable to probably the best FPGAs for reliability from other companies. This is also a much smaller package, much better power profile. I think we're talking about less than 500 milliwatts, maybe 100 milliwatts, depending upon your design. They talk about the power here. So very low power, very good system for very affordable system as well for space grade FPGA. And you can also find it on the Frontgrade website, where they talk about upsampling it, getting it certified and available for space deployment. Do they have any good comparisons on the mitigation side? Okay, talking more about the architecture here. But like any FPGA, SRAM FPGA or whatnot, you have single event upsets, which aren't a big issue on this with this silicon package. It's much lower. You still have them. You can have a scrubber that fixes them, but like an FPGA, you can implement a soft processor. And with the NOEL3 processor, this way you can have a RISC-V processor with your FPGA, making this Lattice FPGA actually a very comparable product to a lot of rad tolerant, rad hard processors, which are usually much more expensive and much more locked down, not as versatile as using an FPGA. So being able to do a soft processor, leaving enough fabric to handle the other peripherals and accelerators you want, gives NOEL3 on the Lattice Certus and Certus Pro a really good product for space. So we want to look at the example design. Have that up here. And this example design just goes over more interesting on the barrel architecture. Pipeline block diagram. They talk about the different hearts here. Okay, it's the inches unit. Talk about the debug bus. CSRs from the control status registers. So we're going to the example design right here, and we're going to load this onto our GR740-MINI and deploy a few different systems. So using the newest GRMON 4, so GRMON is their debug tool, and this allows you to connect to their debug bus, and it has a bunch of utilities. I think you get GDB hooked up to it. So this is very useful to interact with their system on chips. This is a great tool for the system on chips you can deploy with their libraries. So we're going to first connect to the processor. So this is going to be connecting to the Leon 4 processor using the Spark architecture right here. And once you get into these systems, you can always go info sys, and they'll give you detailed information on each system. You can even like go further, like we do info, what's it, PCI here? This PCI. Do we have to use a name? PCI 0. And you can get more information of the memory bus window and other features within it. PPIO 1, like this. Yeah, more information. But for now, we're going to be loading the FPGA. So you can download the bitstream from their website. and we can load it. This is using a modified OpenFPGA loader to load it over the FTDI chip into the FPGA. So this is in the process of programming the FPGA. This is the host computer programming the FPGA in this situation. Takes a bit of time at the 1 megahertz, but once you're done, you can then connect to the FPGA system. Zoom in a little bit. So here we're going to connect to UART3, which is going to be UART1 right here. So this UART3 on my machine is UART1 over the FTDI chip connected to the CertusPro. So we're going to use that to connect to the system of the NOEL3 processor. We have the NOEL3 RISC-V processor, the 2 debug links. We have the generic UART, the timer UART, generic IO ports, and we can do info sys, and we get information on each of the subsystems, and we can dig down into these systems for further detail. I think there's a way we can actually look at the register map. Red UART 0. Let's see. There's a way you could look at the subsystems. Info wanted. Info reg UART 0. What we want to do. Okay, so we can look at the registers and the UART 0. We can do CPU 0. Look at the ISA extension, status registers, the capability registers. Nothing there. Just curious if there's anything else worth looking at. Okay. Try loaded. Okay. Oh, and back to info sys. So we have the CPU, we have the instruction memory here, we have the data memory here, we have the GPIO bus here, and then we have what's connected to this subsystem. Debug module for the different hearts. So there's only 3 hearts here. I thought there's 4 hearts. So this must be a 3-heart system. I really want them to release the NOEL3 code in the next GRLib, and we can break down the different heart configurations and look at the utilization. It'd be really interesting. We can get that running on RTX FPGA as well. So we have a few software demos we can work through. So going back to the website here, under the NOEL3 examples, there's example software. And in that example software, there is a README. Find where my README went. Okay. So this README, it talks about the different ELF files that the GCC that was compiled on it. And what you can do to execute the commands. They have a little log where you for the UART, you load the dry stone and you run it to get the dry stone MIPS. Do they talk about dry stone MIPS per megahertz? I don't really talk about the speed of this system. Does it report the clock rate here? We report. Is it at the... Okay, 50 megahertz. We have the dry stone MIPS. And then we have the demo ELF, which is doing various different applications on the different hearts. Okay. So let's go ahead and the forward enable the UART, and also load I don't have it here. I'm just gonna have to find it again. We're going to load home tech GR740-MINI. Right. So we're gonna load the Drystone ELF into the system. Zoom in a little bit here too. And then we're just going to run. And we loaded the instructions into the instruction memory. We loaded the data into the data memory here. And then we have the Drystone output of the system. Okay, we have a question on YouTube. Sorry, that was a few minutes ago. What is the external PROM IC used for connecting to the Frontgrade? It had internal flash for code. No? So for the Lattice FPGA, we are only using the FPGA. We're not using any external memory at the moment. But there is an external QSPI flash for initial configuration and maybe some user code. And then you have a DDR3 memory for operational memory. There isn't the other Leon processor on board, but we're not interacting with it at the moment. Does that answer your question? If you have other questions about the memory on this board, we can talk more about it. So we were able to get, I think, the same performance. Let's see. Um, 25, 38941, 22.8. So yeah. Oh no, difference there. This was on the Kintex board, or at the KU40 board. Everything else looks identical. I don't know if we can't really play around with the ELF file at the moment. So that's the Drystone ELF. And we can go ahead and run a demo ELF. And we'll run that. We should hopefully get the same output. Might have to reprogram the FPGA. But this is running the floating point test on the different hearts, multiply divide, deterministic bus access, counter, sum array, mix test, and it goes through the various examples. Frontgrade hasn't released the code for this, but they do have an open source repository called grlib. So we look at the grlib right here. There's the source code. They updated it last in July. I assume they're going to have an update soon with the NOEL3 and the software. But for example, if we jump into let me go into the more recent grlib. So if we go into the most recent grlib here, they make their bit files on Mac. So if we go into software, they have the different examples. There's no NOEL3 in their current iteration, which I assume they'll be releasing soon. But on the NOEL5, they have like a sys-test, they have linker scripts, startup scripts, makefile in the software with the various drivers, and a makefile. Right? And they're using, for their makefile, they're using a RISC-V Gaisler compile. And if we go back here under compilers, they also pre-compile your NOEL5 RISC-V. So they give you a compiler. You can use that to do cross-compiling for the system. And they hopefully will have example software. Another place to look is in the boards. Well, this is where GR740-MINI constraints and whatnot are listed. But in the designs, which you should see in the NOEL3 coming up here in the future. Currently, we only see the NOEL5. But we can see the NOEL5 listed on some CertusPro eval cards. And I think this is where This is where you get your configuration. So it'll be interesting to see what configuration is available for the NOEL3 processor and what resources we are. We can change performance resource design space is available in the library under grlib. Is it under Gaisler? Might be under Gaisler. So here's the RISC-V. Those are just different things. So let's go back to the lib under Gaisler. Here's the NOEL5. So that assumes there'll be NOEL3 in the system in the future, and kind of talks about the different settings you can do. Okay, so that's where the source code is, and you can download this, you can look through it, and you can implement the design. So you wanted to know about the PROM that's on the board. Oh, the EPROM. That must be the FTDI configuration. I haven't seen that before. We could, let me see. Let's see. For the FT4232 HPQ. Let's see what interface is available here. Documentation. UART. Bang. I don't know why this has a flash on it. Type-C connector. Okay, the config. Okay, so the config is stored in an external EEPROM. So there you go, have the EEPROM connected to the system. And it handles 2 different Type-C connections, which is really nice. I like that. Might use that. Some ideas I have. Okay. So since we have the tool chain, since RISC-V is relatively easy, I went ahead and made a basic linker script, and I've used some old, I guess, standalone library files I have to set up the RISC-V. And I created a really basic Hello World application here and compiled it for the system, and we're just routing it to the memory. I couldn't get the UART to work. I think I need to wait till they release their full kind of board support package for the NOEL3, and then we can do some really fun custom software for the system. So I can show you what happens when we try to run it. Not completely happy. So we can load my custom Hello World, and we can run it, and it'll eventually the UART will go crazy right here. So we have the UART going crazy, so we'll kill it. But if we do mem for right here, we have Hello World over here. So I'm not sure what is happening on the other hearts or what I caused to happen in the system, but I think it'd be really useful to do a future video once we have the official BSP board or processor support package, what we want to call it. We can get GDB connected, we can step through code, and we can show you how we can easily develop for this embedded system. We can use GRMON with GDB to do breakpoints, do watchers and registers and memory locations. We will load different things with like an OpenOCD GDB connection, and that way we can interface with the system. I think that's most of the stuff here. I don't have the source code to dig in right now. We just have the precompiled solutions at the moment. But we can potentially use the GRMON guide. So we go to debug tools. We go to the GRMON user manual. Maybe we can find some additional things to probe within the system. To have okay, so they do have an IDE that they do have connected. This looks like it's running on Windows. Okay, let's see. Where is this graphical interface? Is it Windows only? Is there a GUI? The Windows solution provides a GUI. We might be able to open it up. It might just take too long at the moment. Okay, here. Okay, does that say there's a GUI? Must be the Windows build. Maybe the evaluation doesn't come with the GUI. Okay. Go look at that real quick. Okay, any other questions? We have a question from Twitch saying hi. Any other questions from Twitch, YouTube, and LinkedIn? I'm gonna see if I can get this GUI working. Maybe we can plug it into the other system. Okay, it looks like the eval version may not have the GUI as described in this documentation. That was a GRMON 3. Oh. See if this has the GUI. Yes, this must not be the eval license. Yeah. So the GUI doesn't look like it's working for the current licensing. Okay, we'll have to. It must be the only CLI version we got. So I'm looking forward to the GRlib update that should have the new NOEL3. But before we do that, we can look at some of the utilization examples that we have for here. So one of the things about the NOEL5 processor is it used up a large chunk of the FPGA. We're talking close to 90%. No, that's less. That's probably half of the system using different NOEL5 configurations. So the NOEL3 should be much smaller. So I'm excited for NOEL3, excited for the different place and route, or the different utilization options, performance options, and how they can be placed and route on the RD FPGA, the Lattice FPGAs. We also have the PolarFire FPGA. They also have the Nano Explorer right here, the Nano Explorer FPGA as well, where you can see the utilization on the system. Nano Explorer is a really interesting FPGA coming out of Europe for fault hard implementations. I see they did percentages as well. So all this information is public. You can download the source code, you download the example files, download the debug tool and whatnot for their basic evaluation licenses. So Frontgrade, I think, offers a lot of support for being able to explore their designs on different subsystems. You don't even need to use their development boards. For the NOEL3 examples, we also have the Avant FPGA, we have the PolarFire Splash Kit right here, and we have the Kintex UltraScale board here. Once they release the source code, you can easily implement that on any FPGA, and we can demonstrate that once they have the new GRlib update, and we can go through the process of trying to use their tools and make files to get it working, and maybe look at using that with other open source code. We can maybe look at trying to implement the GRlib processors and peripherals of LIDEX. How can you fuse two different open source systems together, include your own? So I think that'd be interesting to look at. But that's kind of all I have prepared today. We have another question on Twitch. Sorry, I've been distracted. So I do have, we'll be looking at the Altera FPGA on Friday. We're looking at DDR interfaces, but hopefully we can look at some additional systems in the coming weeks. I need to work on my schedule to figure out when would be best. Well, thank you for coming today. I know it wasn't, I would say, a mainstream topic, but it was something I wanted to explore. Okay, so we have another, sorry again, about the prom. So you want to know about the prom. Okay, so this is a GR740. This is going to be the non-volatile memory for the processor system, right? So the prom is going to be software for for the Leon for quad 4. So we're going to have the software, the loadable software, come out of here, and then the SD-RAM is for the volatile code. So that answers that question. If you have any questions about Lattice, RISC-V processors, FPGAs in general, feel free to leave a comment on this video after it's been posted. You can also join the Discord and join our Discord to ask any further questions. Feel free to provide feedback on what you want to see next. But I think that's all we have for today. I need to figure out what's a good link for these videos, but that's the content I have available. We will dig further into Frontgrade and their GRlib when they have published a new release. I think the NOEL3 is actually really interesting. Well, thanks again. Feel free to join us Friday or future streams in the coming weeks. Once we can go back to our thing here, YouTube, Twitch, LinkedIn, our X as FPGA Zealot or Andrew Wilson. Feel free to follow and like.